Alright, so let's take a look at the vertex formula. Let's talk about that real quick. Okay? The vertex formula is a formula that the government or the standards, math standards, Common Core wants you to know. I mean, basically because most pre-cals in the United States in college are starting to use vertex formula. Now, when I went to college, we didn't do vertex formula, but lots of things change over the times. So I had to learn this a couple of years ago. It is difficult, but as you get to know it, it becomes pretty easy. The key to the vertex formula is this. The vertex is H and K. And that's why it's called the vertex formula. Because the formula is made up of x minus h squared plus k. Now, if we think about that, if we think about what we've been doing, right? The inside is what? Is that horizontal or vertical? Horizontal. Okay. So this is the horizontal. And lie. Okay? So horizontals are always do the opposite. Right? They always do the opposite. So what's happening here is whenever H is in here, it's the opposite here. Does that make sense? So X's do the opposite. So the H is always the opposite. Okay? And the inside is a shift, right? When we're adding or subtracting, that's a shift. Okay? So vertex formula doesn't work with stretches and compression. Okay? They work with shifts. You got me? Okay? Only with shifting. Okay? So when we're adding to the x or we're adding to the y or the whole function, the f of x, right? The f of x is your base function. When we're adding to that x squared function or adding k, right, we're shifting it either negatively or positively. We're adding a negative number or a positive number. Okay? That's that vertical or horizontal? Outside. Vertical. Okay? And so they always tell the truth. Okay? And so you just think of the vertex formula is really simple if you break it down as, okay, it shifts your middle point, or basically all points, right? Up, down, left, or right. That's it. Up, down, left, or right. Okay? And if we think about that, if we think about the vertex formula for this one, okay? Is this up or down on the outside? The outside you said was vertical, since I already have the green in my hand. Vertical, so it's an up or down? Down 9. Down 9. Okay? So this is down 9. Okay? And since we know it's shifting, we don't need to say shift, but we could. We could say vertical shift down 9. Okay? Then what are we going to say for the x? What's happening there? Up 4? Almost. It is opposite, but remember it's right 4. Remember, x, that's why I said almost, because it's x's go right or left, right? Horizontal. So we know that's horizontal. And I like the fact that you made it opposite, right? That's what we need to do. So it's horizontal, it's opposite of left, so it must be right. Okay? Opposite of plus or minus is plus, and plus is right. Okay? So right 4. Okay? So if we're going to graph that, we know that the original function is this, right? So we graph the original function and we move it right 4, 1, 2, 3, 4, and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which would totally mirror these, right? Okay? And so our new point is here. Right? But we have to graph those 5 points. Remember? I want you to have those 5 points every time. Okay? Do you remember what those 5 points were? Up 1 over 1. Up 1 over 1. Up 4 over 2. Up 4 over 2. Okay? And now we have our graph.
So what did you do?
Okay? So I went up 1 over 1, right? And then I went up 4 over 2. Because I took that original x squared, that original f of x equals x squared, and I moved it down 9 and right 4, or right 4 and down 9. That's all I did. I picked this up and I moved it. That's it. So this original one was up 1 over 1, up 1 over 1, up 2, up 4, over 2, up 4. Right? So all I did was move those points down. Does that make sense? And that works for your vertex formula. Okay? That works for your vertex formula. Alright. What vertex formula doesn't do. There's a lot it doesn't do. That's why I almost don't want to teach it. Normally, when I taught in college, I chose not to teach it in my pre-cal because I'm like, this barely ever works. And the same thing with completing the square. I think it's a waste of my time, right? Completing the square, because I'd rather just do quadratic formula, because it works all the time, right? Completing the square only works once in a while, okay? And same with vertex formula. It only works when it's in the vertex form, right? If it's not in vertex form, you got to either change it in the vertex form or do my 5-step method, which maybe Caitlin remembers a little bit, but probably not. I don't want to put her on blast, but she might if I showed it, right? So I got to start thinking about too. What did we talk about in the first chapter? We talked about stretch and compression, right? Okay. When I showed this to, did I show this to you guys yesterday? This one? Only to pre-cal, right? Okay. They were like, what are you doing? What we did last year. So, in a year, it will be very easy for you to forget, especially if you don't use it. Okay? So, when something multiplies on the left, right? But it multiplies the whole function, because this is different. You see the difference between this and that? You guys see the difference between those? You see this is squaring the 4 over 7, right? But this one is not. Okay? So this is 4/7 times everybody, right? Times the f of x. So what kind of, is this horizontal or is this vertical? Yeah, it's vertical. It's outside, right? So this would be vertical, and this would be horizontal, right? If it were inside, right? That would be a horizontal. And a horizontal would be flipped, right? So to put that inside, I would have had to flip it. So I would have done a stretch of 7/4. You feel me on that? That would have been a horizontal stretch of 7/4, because for me to put it in there, I would have to flip it. You remember that? You flip it. Okay? But for this one, this is a vertical of what function? And is it stretch or is it compression? Which one? Yes. Compression. Why? Because it's 4/7, because it's smaller than 1, right? 7/4 bigger than 1, that's why it's a stretch. 4/7 is smaller than 1, that's why it's a compression. And then you said vertical compression of a factor of 4/7. Okay? So that's what we're doing. We're multiplying. We're multiplying that factor. Okay, who's with me on it? Good? Kinda? Okay? Good? Nice. A lot better than pre-cal. That's good. Okay? Alright. The next one. The next step to this. Graph it. This is where it kind of went crazy for them. They were good with it too here. And they were like, oh. Okay? So, it's like, Scooby? Alright, so. Right.
Do we write anything for the parentheses?
The x squared? No, because that's your f of x. We're just gonna call that the f of x of x squared. Okay? So what you're doing is you're compressing. You could say the f of x function of x squared. I'm not gonna make you do that. I'm just kind of getting you to understand what did we do. We did a vertical compression of a factor of 4/7. Vertical meaning the whole function, right? That means that this first graph of over 1, up 1, over 2, up 4, right? Okay, this first graph, okay, gets moved. Okay? It gets moved. Or does it? Does it move? No. It gets compressed. It's like, I'm going to go sit on it. And if I sat on it, think about if I compress something that looks like this. If I compress it, this is hard for me, so pay attention. Okay? If I compress this, I open up. Right? I open up. Can't open up a lot because I'm not very stretchable. Okay? So, but I open up. Okay? So, this is going to open up. How far? 4/7. Good. So we're going to take these points and we're going to say, hey, what's 4/7 of 0? 0, right? But what's 4/7 of 1? What's 4/7 times 1? 4/7. So if we go over to 1, but the answer, when you plug that in, is going to end up being 4/7 of 1, right? So it's 4/7. So that means it's somewhere around here, right? Okay? And then, what's 4/7 of 4? So think about that. 4/7, right, of 4 is 16/7. Okay? So how many times does 7 go into 16? Twice. With how much left over? 2 and 2/7, right? So that means it's going to be 2, instead of 4, it's going to be 2 and 2/7. And this is where they're like, right? Because it's a little bit difficult to think about. Right? So I'm going to try to make it easy. First of all, did that compress? Like we wanted it to. Right? It got wider, right? So it did two things. It either A, compressed, or it horizontally stretched. Right? Horizontal stretch, or compressed. Right? Okay? So, now we got to think about this. Why did I multiply by 1? Why did I multiply by 4? Why am I doing that? Think. What are your outcomes here? X and Y. Okay? X is 1, 0, -1, right? Or 2, 1, 0, -1, -2, right? Whereas we have 4, 1, 0, 1, and 4. Those are your answers. Those are your outputs. If you put in 2, you're going to get 4, right? Because 2 squared is 4. If you put in 3, you're going to get 9. Does that make sense? Okay? So, what's happening here is that's your f of x. That's your y. That's your f of x. Okay? And you're taking that f of x and you're multiplying it by 4/7. So all you're really doing is saying 4/7 of 4, 4/7 of 1, 4/7, and that becomes your new g of x, right? And your new g of x becomes 2 and 2/7, 4/7, 0, 4/7, 2 and 2/7.
Negative.
No, they stay positive. Remember, because they got squared, so that all these, basically it's just this times 4/7, boom. 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 Remember we did that a while ago when we wanted to change to the g of x in chapter 1. And if we only change the vertex, right? Not the vertex, the vertical, we would only change the function by the stretch or the compression, right? So all we had to do. Now, if we change the horizontal, we change what? We change x. That would change this side, which would eventually change that side also. That's why I was saying, when Miss Markey said, well, it's the same, it's not quite the same. Especially when you get into squaring, okay, or quadratics, cubics, and stuff. It's not the same anymore. It's not even close. It's still not the same in linear all the time. It looks the same a lot of the time, but some of the times it gets messed up. And that's why I was like, you have to set this up so you have your parentheses, right? Remember that? Have your parentheses. You followed by. You have to have those parentheses. Okay? Because if we change this function, that will change this function, and it will be a stretch, but it will not be the same stretch. It will not look the same. You feel me? It'll be a different stretch. Because now we're multiplying this x by 7/4 and then squaring it. It will still look like a stretch, but it will not be the same stretch. Okay? So, that's what we got to do. We have to take all our knowledge from 1 and use it in 2. The knowledge we had was very simple. If it's outside, it's vertical. If it's multiplying, it's a stretch or compression. If it's adding, it's shift. If it's inside, it's horizontal. If it's adding, it's a shift. If it's multiplying, it's a stretch or a compression. And that's it. It's the same stuff. Okay? Same stuff, a little harder. Because you have to multiply out those fractions. Okay? So let's look at the next problem. I'm going to pause that, and then I'm going to look at the next.